For this show, we're being asked to estimate and calculate the area of each circle. We've got 2 circles here. Round your answers again to the nearest tenth, 1 decimal place. So estimating area is pi r squared, so 3 times, well, we've got 7 here. What are we going to use? 7 is kind of close to 5. So let's do 7 times 5 times 5. Well, 3 times, actually I'm going to do it this way. 3 times 25 gives us 75, and in this case, centimeters squared. So there's my estimate. For calculating, pi times r, so 3.14 times 7 times 7. So this becomes 49. This is 3.14. And when you do that calculation, 3.14 times 49, you're going to have an answer of 153.86 centimeters squared. But we're going to the nearest tenth. So this is my tenth. The next digit is a 6. So when I drop that, this becomes a 9. So 153.9 centimeters squared approximately equal to. Now, let's compare these numbers. 75 and 153.9. This one is more than twice as big as this one. Now, that seems like a pretty big discrepancy. But let's look. I used 7 and 5. What's the difference here? 5 times 5 gives me 25. 7 times 7 gives me 49. That's almost twice as big. And 3.14 is bigger than 3. So this number is going to be approximately 2 times bigger, if not a little bit more, which is what we're seeing. Now, is using 5 a reasonable estimate? Well, 10 is kind of close to 7 as well, but it's 3 away, whereas this is only 2 away. So this is actually closer than using 10. Now you could use 7, and you could say, well, I know that 7 times 7 is 49, so estimating that's kind of close to 50. Multiply that by 3, about 150 would give me an estimate. And that might actually be the smarter way to go for an estimate, but that's a more complicated estimate to get to, because you're having to use the original numbers and then do, original numbers and then estimate partway through your calculation. Let's have another look at another example and see what happens on this one. So here my radius, I just realized something. This is my diameter. This is not my radius. My radius is 3.5. So I'm going to say that for my estimate, I'm going to keep it at 5. That's fine. Over here, my numbers are wrong. My numbers are wrong over here. Because I didn't use the radius, I used the diameter. So the radius is half of the diameter. So in this case, 3.5 times 3.5 gives me 12.25 over here. And now when I multiply that by pi, or 3.14, I get 38.465 centimeters squared. Round that now to the nearest tenth. That's my tenth. The next one is a 6, so my 4 is going to bump up. 38.5 centimeters squared. Now, this is interesting. Now that we've corrected it, my estimate is approximately twice as big as my calculation. Same kind of concept here. 3.5 is not real close to 5. And then when you square it, this difference becomes exaggerated. So we have 25 versus 12.25. That is now less than half. So that's why these numbers vary. Now, Those should be the correct solutions now that we've used the radius and not the diameter. Let's have a look at part B. Pi r squared. Radius here is indicated as 14.8 meters. For my estimate, I'm going to use 15 meters. 3 instead of pi, and then 15 meters times 15 meters. Well, 15 times 15 is 225 meters squared. And I'm multiplying that by 3, so I have 675 meters squared as my estimate. Let's look at my calculations. 3.14 for pi times 14.8 meters times 14.8 meters. So 14.8 times 14.8 gives me 219.04, and then multiply that with pi, and you're going to get an answer of 687.7856, but we're going to 1 decimal place, so that's 687. That's my 1 decimal place. Next digit is an 8, so I'm going to bump that up. 8, and we're talking meters squared. 687.8 meters squared as opposed to 675 meters squared. Very close together. So I had a reasonable estimate and a good calculation. And that's your Show You Know.